Hi folks, we're going to take a look at page 399, number 6. So let's start with A. It says, for these two vectors, determine the scalar and vector projections of P on Q. Okay, so let's start with the scalar projection. Okay, so we have the scalar projection of P on Q. Okay, so remember this is how we write it. This is when we're projecting, this is what we're projecting onto, and that's given by P dot Q divided by the magnitude of the vector that I'm projecting onto. So notice how when I'm giving the formula, I try to always say what each of these things represents. Okay, so it starts with P dot Q. So we have 3 times -4 plus 6 times 5 plus -22 times -20 all over the square root of -4 squared plus 5 squared plus -20 squared. Okay, so let's simplify this thing here. Okay, so let's go -12 plus 30 plus 22 times 20 equals 458. Okay, and here we've got, in the denominator, we've got 16 plus 25 plus 400. Okay, and I believe that is a perfect square. There we go, 21, and there we have it. Okay, I don't think either of these, so this is not 9 plus 8 is 17, so it's not divisible by 3. I doubt 458 is divisible by 7, but let's check it. No, it's not. Okay, so here we have the scalar projection, which again is a scalar quantity. So now let's go and find the vector projection. So here that's just projection of P onto Q. Now since I've already found the scalar projection, I'm going to use the fact that I've found this already and not start from scratch. Okay, so we know that the vector projection is just the scalar projection, okay, times the unit vector in the direction of what we're projecting onto, in this case here Q. Okay, so I just need to multiply this by the unit vector in the direction of Q. So it's just Q over the magnitude of Q. Okay, so here we have 458 over 21. Q is -4, 5, -20. And the magnitude of Q we already found was 21. Okay, so here what we have is, and it doesn't look like I'm going to have any simplification when I divide out the 21 squared. Okay, so here let's calculate the individual components. So we got 458 times -4. So we have -1832 over 21 times 21 is 441. Okay, then we've got 5 times 458, 2290 over 441, and lastly we have -20 excuse me, times 458, so -9160 over 441. Okay, and of course our final answer is a vector quantity. Okay, and it's always preferable to multiply things in. Having said that, if you left this as 458 over 441 times that vector, that would be fine also. Okay, so let's go back to part B. It says determine the direction angles for this vector P. Okay, so let me rewrite vector P here. So part B, P is 3, 6, -22. Now we had already established the equations that that ruled the direction vectors for this vector even before we talked about projections. Okay, and we have the vector to the x, y, and z axes are given by alpha, beta, and gamma. So we have that cos of alpha to the x-axis is just given by the x component over the magnitude. So here the magnitude of 3 squared plus 6 squared plus -22 squared. So here 3 over, let's calculate that here. And we have 9 plus 36 plus 22 squared, 529. Let's see if that's a perfect square. Oh, yeah, it is, 23. That's nice. Okay, and so now we can calculate alpha, which is just inverse cosine of 3 over Oh, sorry, that was 23, not 32. That makes a bit more sense. Okay, so 3 over 23. And so here we've got inverse cosine of 3 over 23. Okay, 82.5. Okay, and now similarly, we find the direction angles for the y-axis and the z-axis. So here cos beta, so that's to the y-axis is the y component, 6 over the magnitude of the vector, which is just again 23. So beta is cos inverse of 6 over 23, which is equal to cos inverse of 6 over 23. Oh, there we go, 74 point, sorry, did I do that correctly? Let me just try again. Cos inverse of 6 over 23. Oh yeah, 74.9. Sorry, I felt like I clicked something incorrect there. So here we have 74.9 degrees. And lastly, the angle to the z-axis, which is given by gamma. So cosine of that is negative 22 over 23. And right away, now that I notice that that cosine value is negative, I know my answer should be greater than 90. So if I don't get that, it means I must have made some mistake. Okay, so here we have cos inverse of negative 22 over 23, and we have 163. Okay, so there we have it. So again, just a review of these direction angles, okay, given by our 3 cosines. Okay, and just to recap part A, make sure that we understand the difference between the scalar and vector projection. Okay, and remember that the order is projection, the vector we're actually projecting, and that's the vector we're projecting onto, and that's the magnitude that we find in those